Hi, good day, everyone. It's good to have you here. Today, we will be looking at some of the important topics to look into when you're writing chemistry jam, and you need to take cognizance of some particular topics that have repeated in jam chemistry. So today we'll be looking at some of these topics, and we'll be looking at some interrelated topics and see most of all these topics that are constant in jam chemistry. Now, for some of you, it's your first time. It's going to be a little bit new to you, but if you listen to everything I have to say to you on this video, you'll have nothing to be scared of. Chemistry is chemistry, and just that the way it's been arranged is different from that of WAEC. Jam has their own syllabus, and WAEC has their own. So it's very very pertinent that you work with the JAM syllabus since you're taking JAM. Now, you need to understand that the most repeated questions comes from these topics I'm going to relate to you. And one of them is composition of matter. You need to look at the composition of matter, whereas the question has been asked for you to find the composition of mass of an element in a particular compound. Remember, compound is a combination of what? Two or more elements chemically combined together. So let's say, for instance, you're asked to find the percentage of nitrogen in nitrogen, let's say in HNO3, which is trioxo nitrate 5 acid. It asks you to find the percentage of nitrogen. So what you look for is the atomic mass of nitrogen over the atomic mass of the compound, which is trioxonitrate 5 acid, times 100 over 1. You need to be able to calculate empirical formula and molecular what formula. JAM asks this question in two different ways, and it's always repeated. Now, the first, it will ask you, they ask you to find the empirical formula and the molecular what structure. And sometimes you're given molecular mass, and they ask you to calculate what the molecular what formula. Sometimes you are not given. Sometimes there's a relationship between what a molecular mass and vapor density. In a question that has to do with empirical formula, if they ask you to find the molecular what formula, and in the question you are not given the molecular mass, please note, if you're not given molecular mass, you'll be given what vapor density. So molecular mass is 2 times vapor density. You need to take note of that, please. And the next thing you need to understand is there's a relationship between numbers of moles and Avogadro's constant, which is 6.02 times 10 raised to power 23 atoms, and what atomic number or atomic mass. There's a relationship between that three words, those three relationship. There's a relationship between those three terms that you need to understand. That when you're asked to calculate numbers of moles of a particular compound, numbers of atoms present in a compound, and please note the difference between what atom and molecule. An atom is the smallest part of a compound that takes a compound or an element or a substance that takes part in any chemical reaction, while molecules is the combination of two or more atoms. So we are saying molecule, that means you have two or more atoms present in a particular what element. So please take note of that fact. That's why the difference between H and H2. H is one hydrogen atom. H2 substitute 2 means what? Two hydrogen atom, which is equal to or equivalent to a molecule. So having know those basic relationship, yes, you need to understand mixtures and compound and a little bit of relationship. And please, you need to read up on separating techniques. You need to understand the instrument used in separating most of all these mixtures all over. So please, you need to know that. You need to know your centrifugation, you need to know your evaporation, and you need to know your filtration. You need to know your separating funnel. You need to know most of all these separating what techniques they use in separating some of these mixtures. Having said that, now you need to understand electronic configuration. It is very, very important. You need to understand electronic configuration. You need to read through and understand electronic configuration because you would not escape a question from it. Understand some principle that governs it, like Habermas principle, Austri's principle, Pauli exclusion principle. You need to understand how atoms behave in their ground state and their excited state. You need to understand this relationship between them. Alright, you need to understand all of that. So the next thing we'll be looking at now, after understanding electronic configuration, the next thing you want to be thinking now is how to relate isotope with what? Atomic structure. You need to be able to understand what consists an atomic structure. An atomic structure consists of two major parts, which is the shell and the nucleus. Deep down in the nucleus, you have your what? Neutron and your proton. Now, why the electron orbits around the shell? The mass of the proton is 1, the mass of the neutron is 1. Why the mass of the electron is 1/8560 times that of neutron and the proton. That's why the non-shell, the electron, contribute lesser percentage of mass. Actually, the weight of electron is negligible, but it's very, 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 very small. Periodic table is actually one of it, so there is no how you can escape periodic table in your Jamb Chemistry. So that's as much as you can to read up and understand some few things on periodic table. The next thing that we cannot escape is chemical combination. Chemical combination. So when you're talking about compound, you're looking at the combination of what, two or more elements that is what chemically combined together. Now, in chemical combination, there are some factors that affect the way chemicals combined together, the way elements rather combined together. There are some factors that influences it positively or negatively, and you're going to be looking at some kind of bond that bonds these elements together. You'll be looking at electrocovalent bond, you're looking at covalent bond, ionic bond, you're looking at metallic bond. Now you need to understand these bonds and most of the examples. Now you need to understand what happened between what a non-metal, such as hydrogen bonding with let's say oxygen to form water. You know the kind of bond that is with covalent bond. So you need to understand bond between what metals, bond between non-metals. The next thing you need to look at now, you cannot escape calculation under theory of gases. We have your Boyle's law, you have your Charles law, Gauss's law, Graham's law of diffusion, and so on and so forth. You need to understand the calculation at the snap of your finger. These laws are actually talking about relationship between volume and temperature. You look at pressure. So the next thing we're going to be looking at now, you will look at water. It means you look at water, purification of water, hardness of water, and softness of water. It's very, very pertinent that you need to look into that. You need to study it for the sake of Jamb Chemistry. Now, there's something you will never escape, which is what solubility. Solubility, it's a must. Like it's a must. You need to come. You need to study it. It's a must. You need to study. Yeah, you need to understand. Solubility is all about solute plus solvent gives you a solution. What happens if the solute is more than the solvent? What happens if the solution contains more solutes? And there are some calculations that are involved in solubility. Now you need to understand the solubility. We're actually looking at the concentration of the solutes or the volume of the solvent. That's what we're looking at. That's when you have your C1V1 is equal to your C2 and your V2. You need to learn how to calculate amount of substance in gram per dm cube and in mole per dm cube. It is very, very important, especially when you have to do what acid, base, and salts. So please, then electrolysis, please. Electrolysis, it must come out. Electrolysis must come out, and do not look at the first law. Jamb will never ask you anything based on the first law. It's the second law, where elements involved. Now you need to understand your electrochemical series, how metal are arranged in electrochemical series. You know, the first should be your silver because it's the most conductive metal, followed by what? Your copper, aluminium, zinc, and so on and so forth. Now, there's every tendency for silver to displace any of the metal that is beneath it in the electrochemical series when it has to do with an electrolyte. So you need to understand. Please, I'm going to give out a formula that you can use to calculate any second law of electrolysis when it comes to question. And the formula is N is equal to Q over what? NF. I come again. N is equal to what? Q over what? NF. The Q there is representing the quantity of substance. You know, according to first law, Q is equal to what? IT, depending on the parameters you're given in the question. So N there is equal to what? Numbers of moles, which should be what? Mass over molar mass. Why N there is the numbers of Faraday. The Faraday constant is 96500 mole per coulomb. Why the N there? Sometimes you could be given a monovalent element like what? Silver. You could be given a divalent element like what? Zinc, magnesium, and copper. And sometimes you could be given a trivalent element like what? Aluminium. This is Al3 plus. The copper is Cu2 plus. So please take note of that fact. And if you, that formula is very, very important. N is equal to what? Q over what? NF. Now there's something you also need to look at is what? Rate of chemical reaction, chemical kinetics, and it has to do with what? Elements, chemical reaction that is on motion. You need to understand them. And there are some things you need to look into it. You need to look at factors affecting the rate of chemical reaction, reaction mechanism, rate of constant law, and so on and so forth. Now please, chemical equilibrium, Matthias principle, is, you should study it and you should know that chemical equilibrium. Now you need to look at factors affecting equilibrium. You need to look at it. Yes, and you need to read up a little. Literally, there are less calculation on that, but you need to understand your product and your reactant. If your product is more, is it going to favor the forward or the backward reaction? You need to understand that. Now, if I'm having a product of, if my reactants are actually what? 50 kg, and it's less than my product, so you should know it's going to what? To favor the forward reaction. Because at that point, the weight of your what? Of your reactant is higher than that of your product. I want to give you a scenario. If you are playing on a jangilova, some of you in your primary school, and someone that is weighing 50 kg sat on one side of the pivot and you also sat on the other side, you see that you're going to go up because his weight will send you up. Always look at that case when you have to do with what? Chemical equilibrium. The weight of your reactant is that of the product to favor the product. So, and actually you need to actually look at what balancing of chemical equation. You need to be able to balance your chemical equation. If your equations are not balanced, there's no how you can solve problems involving chemical equation. Then you need to look at nuclear chemistry. Nuclear chemistry is a constant topic that do come out every year in chemistry. Nuclear chemistry, you need to understand half-life, you need to understand most of all those elements, uranium and so on and so forth, which read through nuclear chemistry. And please, organic chemistry and the study of what? Hydrogen and carbon. You need to understand organic chemistry, the family of organic chemistry. You understand the archaic group, your fundamentals, like the functional group, the archaic group. You need to understand the family of arcane, and alkyne. And most importantly, you need to understand your functional group, starting with your single bond, your double bond, your triple bond, your alkanoate, your ether, your aqueous group. You need to what? Organic chemistry, and to help us. So you also need to go through volumetric analysis. Yeah, it's actually part of solubility. You need to go through the volumetric analysis, the volume of the substance when you're calculating in mole per dm cube and in gram per dm cube. So with these few points I've highlighted, I think you're all good to go in chemistry. And please do not neglect the simple calculation involved in chemistry. Your more concepts, especially when it has to do with more concepts. Thank you very much. Thank you for being part of our students, and we love you and we always at service to share. I'm sure the management will send more videos as time goes by. Thank you so much.